Alright, pre-AP, this is the last video for ecology. Whoop whoop! 6.4, ecosystem dynamics. So we've talked about individual organismal ecology, looking at one organism. If you look at a bunch of organisms that are of the same species, they make up a population. If you have a lot of populations, different species interacting together, that is a community. And then if you put all the communities together, plant and animal life, all living things, plus their abiotic factors, such as wind, rain, sunlight, soil, all of those things, then you get an ecosystem. So let's make sure we have that highlighter, some type of writing utensil, and let's get this done. Alright, so please highlight that an ecosystem is all interacting communities within a given area, plus, like I just said, the abiotic factors affecting it. So, those abiotic factors, how much rain you get, what kind of soil you have, your temperature, how much sunlight you get during the year, is going to affect some things in your ecosystem, such as, please highlight, energy flow, nutrient cycling, your temperature, and your water. So remember, you can't go very long without water. You can go a lot longer without food. So let's look at some things. And some of these things we've kind of talked about, but we're going to kind of reiterate some things. So again, trophic levels, please highlight. Again, troph means to feed, so these are feeding relationships. And remember, this is going to tell us how energy is going to flow. So primary producers, again, we're going to talk about them. We're actually going to make a food chain and a food web soon. So again, primary producers, these are plants. They're eaten by herbivores, primary consumers. Those primary consumers, those herbivores, are eaten by the secondary consumers, carnivores, meat eaters. So let's make sure we got some things highlighted before we move on and you go, hold on, Miss Minor, going too fast, hold on. So primary producers, highlight, these perform photosynthesis or chemiosynthesis. We just focus on photosynthesis, but make you a nice pretty note out there. Those are my plants. Remember, those are autotrophs. Remember, plants are autotrophs. They make their own food. They're self-feeders. And then consumers, aka heterotrophs. Think about hetero means different, troph means to feed. You feed on different things, you don't make your own food. And then, of course, let's make sure we have differing levels. We have primary. Go ahead, make you a note out beside there somehow that those are your herbivores, such as deer, mice, grasshoppers. And then you have secondary. Those are usually carnivores or possibly omnivores. We can't forget about our omnivores. Remember, omnivores can either consume meat or plants. And then tertiary, we're just moving up another level. And then quantitary. We are a quantitary trophic level. In the words of Timon and Pumbaa, we are on the top of the food chain. So, again, let's highlight this. Primary consumers feed upon the producers. Secondary consumers feed on the primary consumers. And tertiary feed on the secondary. And so on and so forth. And then decomposers. A lot of people, don't give decomposers their proper respect. So I want to make sure that you know what a decomposer is. If we did not have decomposers, ladies and gentlemen, we would have dead plant and animal life just plaguing our planet. They would never be broken down, and it would just be terrible. Just think about if all the roadkill, no one ever picked it up on the road. Can you picture that? Ooh, that's a gruesome thought. So please highlight decomposers. Oh my dear. Decomposers, we call those detriophores. Phores means to eat. Detritus means dead things. So let's highlight. These are the organisms, of course, that feed on dead organic material. That dead organic material, in science, we give it a fancy name called detritus. We're going to learn about and dissect an earthworm, and it is considered to be a detritus feeder. Please highlight that they take dead, decaying organic material, detritus, and convert it back into an inorganic state for the recycling and use of primary consumers. So if, beautiful decomposers like mushrooms, earthworms, bacteria, any type of fungi are beautiful decomposers. There's many different types. And if we didn't have those things, then, of course, we would have those, dead plant and animal life laying around everywhere, but then we couldn't really use it. Again, the environment loves to recycle things and reuse it, just like you do in school, like your paper and your plastic products. We're going to recycle those. Why? Because, let's just get some more use out of them. So, law of conservation of energy, this is where, again, you're going to recycle things. So please highlight, energy is never created nor destroyed. It's just transferred or transformed. And again, we're going to talk about the 10% rule. But before we get on to that, let's make sure that, please highlight, all energy, or E. Remember we talked about energy. We can just abbreviate that to capital E. Enters Earth toward a sunlight. So just like our picture here. And then all energy leaves as heat. So remember, whenever we talked about the 10% rule, whenever you have the sunlight, it allows the plants to go through photosynthesis and make their own food. Well, only 10% of that 1 million, remember joules, that J is for energy, only 10% of the energy is transferred onto the plant for it to use. The other 90% is let off as heat because it has to be able to use that energy. Whenever that grasshopper eats the plant, it only gets to keep 10% of the energy from the plant. So it's 1,000 of that 10,000. And again, 90% of it's coming off as heat. Why that grasshopper has to break down that plant material it ate and uses it for energy. Whenever that mouse eats that grasshopper, again, it's only going to get 10% of that 1,000 for itself to keep. So we're down to 100 joules. Again, 90% of it is coming off as heat. And then whenever that snake eats that mouse, it's only going to be able to keep for itself to use 10% of that 100, which is going to be 10 joules. The rest, of course, again, we're going to keep doing this until we remember 90% of it comes off as heat. So let's make sure we got that highlighted again. So 10% rule applies from trophic level to trophic level. The 10% rule, like I just stated, states that only 10% of the energy from one trophic level will be available to fuel to give some energy to the next trophic level in the food chain. And again, 90% is lost as actually keeping that animal alive. It's going to be given off as heat, metabolism. So let's head on down to where it says and highlight nutrients are recycled in ecosystems, because we want to be able to reuse things because it's already there. Let's reuse it. So again, law of conservation of matter. Matter is neither created nor destroyed. It's just transformed or transferred. Either we're going to build something up or break something down. Alright, so before we move on to part 2, let's make sure that we have the last bit highlighted, primary production. please highlight that that is the total amount of solar energy, that energy from the sun, that's converted to chemical energy. So how much food are plants making through photosynthesis? How much sugar are they making? How much glucose are they making? So we have a global energy budget, and the only thing that we need to know is the global energy budget. Please just highlight it's the amount of energy that the sun uses so that we can go through photosynthesis. Please highlight, this is an interesting fact, only 1% of the solar energy is used to power photosynthesis, which in plants, that will make over 170 billion tons of sugar per year. So that's how much glucose plants will make in a year. 170 billion tons. That is amazing. Please also highlight 99% of the solar energy is absorbed by the water and reflected back into space. So remember whenever we talked about properties of water and that those oceans and rivers and streams and lakes and ponds, they are there as heat piggy banks. And remember that they're going to be there to absorb that heat from the sun so we don't burn up and fry like an egg on the earth. So if you would please, we're done with part 1. If you'll flip over to part 2, I'm going to as well. And we're going to talk about biochemical cycles. And I know that seems kind of scary, but let's break this word down. Bio. Underline that part. What does it mean? Biology is the study of what? Ooh, good job. Life. The next word is geo. Think about geography. What do you learn about in geography? Oh, you're learning about the parts of the earth where different countries are located. And then chemical. Well, in this part, for us, chemicals right now are going to be nutrients. Those are going to be like water, carbon, nitrogen, phosphorus. So in this particular use, we're going to say chemicals or nutrients. So the nutrients of life that's on Earth, that's what we're going to look at. How are those nutrients cycled? Think about a cycle. Runs in a cycle. We're going to see how those are recycled and get used over and over and over. Now, some of these you've heard of, some of these you haven't. So let's look at it. Alright, we're going to look at our first cycle, the water cycle. And most of the time, my students have seen the water cycle. They've either done a little poster about it, what have you. So water cycle. Let's highlight some things before I explain our pretty picture here. So let's highlight that water vapor is created by the sun. So remember, there are, big old nice steps in the water cycle. There's evaporation, condensation, precipitation. You're like, oh man, I have heard those words before. Snap. So, let's jog our memory a little bit here. So it causes evaporations of bodies of water, such as oceans. So, evaporation, I'm going to have the sun radiating down. It's going to heat up this water in the ocean or maybe a lake or a pond. And then it's going to turn from a liquid to a gas. It's going to evaporate. And then it's going to, kind of get stuck in some clouds. We'll get to that in just a minute. I'm getting ahead of myself. Next, we want to highlight that water vapor is carried by the winds almost all over the world. And then it condenses. And remember, condense happens in these beautiful clouds. So condense means that we're going to turn from a gas back into a liquid. Think about condensation on the outside of a cold drink. That's just water droplets that are going to start forming. And they're going to be stuck in this cloud. Please then highlight that it condenses in the air to make rain or snow. Please highlight that's precipitation. So it's going to precipitate. It's going to come on down. And please highlight it returns to the land or the ocean. So highlight eventually water returns to the land. And again, that water is going to go for plants. It's going to go in the rivers. And let's highlight the last part. Plants take in the water and use for photosynthesis, but can also lose it in the form of transpiration in the air. So, whenever this precipitation hits the land, it's going to probably go to a river. And just like, who is that fella in Finding Nemo? That he'd been in the ocean and he told him, Nemo, kid, all things lead to the ocean, which is true. All rivers lead to the ocean. It's going to run back off, go into the ocean, get evaporated by the sun, condense, turn from a gas to a liquid, then it's going to rain on down, go into plants. Plants get too much, they'll excrete that water through their leaves, transpiration. So water cycle, one that you might be familiar with. The next one you may not be familiar with is the carbon cycle. So this is one that sometimes my students find actually to be somewhat interesting. So let's look at this. So let's highlight CO2. So remember, CO2 is what? That's right, it's carbon dioxide. And if you need to make a little note out beside there, because I know sometimes you'll sit there and you'll think, man, I know what CO2 is. Doodle. Why can't I remember the name of that? My goodness. Carbon dioxide. So it's going to be removed from the air by photosynthesizing organisms. For us, it's going to mainly be plants. So CO2, it's in the atmosphere, it's just hanging out in the air. Again, remember, if you remember that beautiful equation for photosynthesis, one of your ingredients, one of your reactants was CO2. CO2 plus water plus sunlight. Well, hot dog, that CO2 is going to go into the plant leaves because it's a reactant of photosynthesis. That plant is going to be able to use it. Now, also algae and bacteria can use this, but let's just focus on the one we know, plants. So let's highlight that because remember, if you want to highlight, if you don't remember this, CO2 is going to be in the development of making sugar through photosynthesis. And then those sugars that are contained in carbon, because remember, I gave you that little beautiful formula for glucose. C6, that's carbon. Well, hot dog, where's that carbon going to go? Let's highlight that it's passed from organism to organism in the food chain. So, these beautiful primary consumers are going to eat the plants. That carbon is going to be transferred from that plant to the primary consumer. Then that higher level consumer is going to eat that primary consumer. That carbon is going to keep getting on passed on. And please highlight that all organisms then release the carbon in the form of CO2. So whenever this bunny rabbit breathes out through cellular respiration, or this, beautiful mountain lion does, it releases CO2 back into the atmosphere. So, cellular respiration. Because remember, plants go through that as well. So let's make sure that we recap before we move on. CO2 from the atmosphere is used in photosynthesis of plants. Plants make glucose, because remember, that's their food source. Well, hot dog. Primary consumers eat plants because they're herbivores. So they get the carbon from that glucose. It goes in their bodies. And whenever they breathe out, they go through cellular respiration, they release CO2 back into the atmosphere. Well, if that, mountain lion right there, or bobcat, my bad, it decides to eat this bunny rabbit, it's going to get the carbon transferred to him because the bunny rabbit ate the plant. And then again, as that bobcat breathes out and goes through cellular respiration, releases carbon dioxide because it's a product of cellular respiration back into the atmosphere. That cycle is going to keep on going. Now, there is one way that humans have put carbon back into the atmosphere, extra carbon that kind of doesn't need to be there. So let's highlight about that. The burning of plant material, natural gas, and fossil fuels, which are the remains of dead plant life. If you would please put out beside there coal, the burning of coal. Coal comes from compressed dead trees and plant material that has been locked in the earth for very, very long. And it, releases a lot of energy whenever it's burned. That's why people like to burn coal. And dead life forms such as dinosaurs. Sometimes those bones have broken down to the point they're no longer bones. They just turn into coal. And prehistoric forest, they put them back into the atmosphere. So burning in factories releases way more CO2 than is necessary. And that's why sometimes we have some problems, like pollution. So this is a form of pollution. Next cycle, the nitrogen cycle. So please highlight the majority of nitrogen is removed from the air by water. Most of the air that you breathe has nitrogen in it. Of course, we breathe oxygen, but we do also breathe a good bit of nitrogen. Alright, please let's highlight where it says the nitrogen in the water is mainly consumed by nitrogen-fixing bacteria in the soil. So, whenever nitrogen in the atmosphere, it will go and it will get transferred into the soil for these nitrogen-fixing bacteria. And they actually get converted over into ammonia, which we'll kind of go over. Usually this nitrogen-fixing bacteria lives on the nodules of legumes. Legumes, if you want to put peanuts, soybeans. So if you've ever seen people rotate crops before, you plant corn one year, that corn depletes the soil of nitrogen, which is a crucial nutrient in the soil for plants to grow. So usually they'll rotate crops, where one year they'll plant corn, and the next year they'll plant soybeans or even peanuts. Why? Because you want that good bacteria living on the roots of these plants to put nitrogen back in the soil. So once that nitrogen-fixing bacteria turns that nitrogen into ammonia, we go through something called nitrogen fixation. Let's go and head down to where it says some ammonia. Some ammonia, please highlight, in the soil is also consumed by nitrifying bacteria, which converts it to nitrite. So let's highlight that. We have some ammonia. No matter what, you could go down this path. Nitrogen-fixing bacteria in the soil turns it into ammonia. Sometimes that ammonia gets turned into nitrite, which is just, nitrogen with an oxygen on there with it. And then please go on ahead to where the nitrates, because after a while we'll turn these nitrites into nitrates. We'll just add another oxygen on there. See, NO2. You add another oxygen. got to change the name. You'll learn that in chemistry. So once you turn that nitrate into nitrites into nitrates. I'm getting my 8's and my ites mixed up. So the nitrates are also absorbed by plants, just as ammonia. And then some other bacteria in the soil can also eat the nitrates. These are called detrifying bacteria. So this bacteria eats the nitrates. It breaks them down. Think about detritus. We break things down. So these are detrifying bacteria. They consume, please highlight, the nitrates and break them down into the oxygen and the nitrogen gas, because this is the nitrogen cycle. We don't really want to deal with the oxygen. And both return back into the air. So here, you're going to have O2 go on its way, and then the part that we care about is the nitrogen. So again, let's start this over just to make sure that you got this. So nitrogen is in the air, the atmosphere. It gets transferred into the soil. Nitrogen-fixing bacteria that live on the roots of legumes like peanuts and soybeans. They turn and make that nitrogen, and they turn it into ammonia, which is NH4. Write it really big. Still got nitrogen on there. It's just got some hydrogens with it. Once that nitrification takes place, this bacteria gets rid of the hydrogen and it gives it an oxygen, turns it into nitrites. Well, then some more bacteria add another oxygen and it turns into nitrates. Well, then this next bacteria starts breaking down and separating that nitrogen from the oxygen, and they both get released back in the atmosphere. Then we start the whole other cycle all over again. So, please highlight that also you can take another path. Some bacteria in the soil can also eat nitrates. Remember, this is where we're starting off again, detrifying bacteria. They are both returned to the air. So this is called detrification. Also, as plants are eaten by animals, like that nice little groundhog, this is the other thing. The nitrogen can travel through the food chain. Whenever that groundhog dies or that plant dies, their bodies will decompose and create ammonia. So let's say that the groundhog and the plant dies. Well, they're going to be decomposed by bacteria and fungi. That's going to turn into ammonia. Then we're going to go this way until it's released back into the atmosphere. Alright, last cycle. Phosphorus cycle. So please highlight that your initial component of phosphorus is in rocks. So we're going to start up here on the mountain where the rocks are. So please highlight as a rock breaks down over time. Remember, if you don't remember this from, 5th or 6th grade, this is called weathering. So whenever that weathering occurs, please highlight phosphorus is released from the soil. So weathering of rock breaks it down, creates soil. Please highlight this phosphorus makes its way to bodies of water, just like this lake or pond, and is available for producers, phytoplankton. They are little bitty microscopic creatures that live in the water, to use to make organic compounds so that they can have, phospholipids. And they're also going to have that DNA and RNA they got to take care of. Please highlight that plants can also retrieve phosphorus from the soil. Why? Because all soil is broken down rock, and make organic compounds. Now, whenever organisms die, like this plant or this animal, this cute little snail, Remember, decomposers, they can actually decompose their bodies and it will actually release phosphate into the soil. Well, let's think about this. Phosphate. You're going to find phosphate in nucleic acids like DNA and RNA. And then that's going to return to the soil. So let's make sure before we move on, temperature effects of cycling rates, please highlight. If there's a high temperature, it's hot. It causes faster cycling of nutrients. So you're going to see a lot of nutrient cycling in the tropical rainforest. If it's low temperatures, cold, it's going to be a lot slower. That's going to be in places like the tundra and even the taiga. Alright, so last part. Part 3. Then we're done. So these are some things that can arise from, humans getting involved in our ecosystem. Sometimes it's good, sometimes it's not so good. So we're going to go through these pretty quickly. So harvesting, please highlight, because you're ripping things up from the ground, you're going to have a loss of nutrients. Also fertilizers. We are replacing the natural nutrients in the soil with fertilizers. Why? We want bigger, better, more nutritious plants. And then there's something called a critical load. Because we want our fruits and veggies to be packed with nutrients, please highlight it's the maximum amount of nutrients that a plant can absorb. And this comes from putting extra fertilizer. And sometimes that fertilizer runs off into the water table, the good old rivers and streams and lakes. And it can actually kill the fish. Kind of what we talked about, fossil fuels. Please highlight, because we burn fossil fuels like coal, we actually get something called acid precipitation, which we'll watch a video about that in class. It's kind of short. Some of the damage that it causes. So this is rain, sleet, or snow that has a pH of, less than 5.6. 6 is the weakest acid there is. Less than 5.6, your stomach acid is about a 2 or a 3. So we're going to see a lot of corroding. So please highlight, this is from sulfur and natural oxides. They're released by, burning that coal and other fossil fuels. And what are the effects that we've seen from it? Please highlight, it kills plants and leeches. Not leeches, but it leaches those nutrients from the soil. It literally sucks the life out of the soil. So this is acid rain in the U.S., which they've actually taken pHs from certain places that they've seen acid rain. And we actually, in the 70s, we figured out acid rain was starting to occur in the U.S., and we actually had bans on burning of fossil fuels and cutting back so we could cut down on our pollution. And you see acid rain more in places like China, Japan, places in Europe where they haven't regulated how they can consume fossil fuels for burning. So this is a tree that acid rain has come down. It has gotten and pretty much just killed the tree, stripped it of all its leaves. It's terrible. So biomagnification, please highlight, it's the buildup of poisons and heavy metals in an organism. And highlight, the higher up in the food chain you get, the more concentrated the poison gets, which causes a lot of health and reproductive problems. We saw this happen with, please highlight, this is something that is caused, we've seen in DDT and PCB. Please highlight that they led to organism extinction, health issues, and polluted water. So what we learned is that DDT used to be, it's a pesticide. It's there to kill bugs on your crops. Well, that DDT got into the water and it infected these phytoplankton, zooplankton. Those are animal-like plankton. The fish ate it. That passed the poison on to the fish. Then the birds, mainly the eagles, ate the fish, and then it got a more concentrated amount of poison. And then we started seeing that eagles, their shells for their baby birds were very thin, and their population numbers started going down because the shell wasn't thick enough to protect that baby bird long enough for it to reach full development and then hatch. So please highlight. We're going to talk about a lady named Rachel Carson. She was one of the ones that pioneered this, saying, hey, something's wrong. We might want to think about not using this thing called DDT. So what is DDT used for? So Silent Spring by Rachel Carson discussed this in depth of how, you let things get into the water. The things in the water consume that poison, and then the fish eat it, and then things that eat the fish, it just gets more concentrated. So please highlight that because she wrote this book, it eventually led to the banning of DDT in 1971. We no longer allow this to be used. So why did we even use it? Highlight, DDT was used to kill mosquitoes. But then it caused the bird eggshells and bald eagles, our national bird, to be paper thin. So whenever the mother would actually go sit on the eggs to keep them warm, she actually ended up killing her babies. And then that's why we saw a dramatic decrease in the eagle population. But they're kind of coming back now, which is good. And then rising CO2 levels, highlight. This is leading to deforestation or breaking down of the forest and fossil fuels. Then the greenhouse effect. This is where you have greenhouse gases that get into the atmosphere, and they say that it's, causing the ozone to get smaller, or pardon me, it's creating holes in the ozone layer. This is one of the images from NASA over Antarctica. That dark blue is supposedly a big old hole that we've created by, burning a lot of fossil fuel and putting back too much CO2 in the air that's not supposed to be there. So that's it for ecology, guys. That's the end of the road, 6.4. I hope this video was helpful, and we're going to do some activities on these things.